Okay, graphing rational equations. We want to take a look at the different forms that might be helpful to us depending on what we're actually looking for. So if we're taking a look at factored form, so factored form is where we would have, I don't know, hypothetically something like f of x is equal to x minus 2x plus 1 all over x minus 2. In this case, we can take a look at the factored form and see if we have any factors that match top and bottom. If we do have factors that match top and bottom, then that means that those factors are going to give us a whole. So we're going to have a whole at, and it's going to be x equals 2. We don't write it that way, so we need to do 2 comma. So we're going to go back and then use the simplified version of this to actually be able to find the y value of the whole. We could also have a factored form that has like g of x is equal to x minus 6, 2x plus 1 all over x minus 6, and then x minus 4. Okay, if we take a look at this, we still have a whole there, but once the whole has been taken out, now we can take a look and see if there's anything else that match it, anything else from the denominator that doesn't match something in the top. And we do. So we have this x minus 4, which means we're going to have a vertical asymptote at x equals 4. Asymptotes are written as equations, so we're not going to find like a y value that goes with it. Okay, the next one we take a look at is expanded form. So expanded form, I don't know, let's say we've got h of x, and it is 4x cubed plus 7x minus 2 all over 5x cubed minus 9x plus 1. And we take a look at the degree. If the degree of the top and the degree of the bottom are the same, then for the horizontal asymptote, all we're going to do is take a look at the leading coefficients. Horizontal asymptotes, horizontal line, make sure it's y equals, and we just grab the leading coefficients off. So that happens when the degree of the top and the degree of the bottom are the same. Let's say that we have m of x, and m of x is another one that's been expanded. So let's do 3x squared minus 9x plus 4 all over 7x to the 5th plus 11x plus 1. And we take a look at the degree again. Notice that the degree of the top is actually smaller than the degree of the bottom. This is an automatic horizontal asymptote at y equals 0. And again, it's a line, so we don't actually like plug in y equals 0 and see what happens. Then the other version is if the degree of the top is bigger than the degree of the bottom. So let's say we've got 8x to the 4th plus 9x squared minus 7 all over 10x plus 5. All right, if we take a look at the degree of the degree of the top is 4, the degree of the bottom is 1 if there's nothing there. If the degree of the top is bigger than the degree of the bottom, then there is no horizontal asymptote. None. Okay, if we take a look at the simplified version, so let's say we're doing k of x, and we could take a look back at the original f of x that we did. So we had x minus 2 times x plus 1 all over x minus 2. Okay, so we knew that there was going to be a whole. So we had this happening. So we knew that there was going to be a whole at, let's see, 2 comma something. Well, to find the rest of it, you're going to use the simplified version. So we're going to take x equals 2, and this new simplified version was just x plus 1. We'll plug that in, that gives us 3. Okay, so now we have a whole at 2, 3. Okay, the other way that the simplified version after taking the whole out is actually helpful is if you're trying to determine if you have a slant asymptote. So a slant asymptote and a horizontal asymptote cannot occur simultaneously because they both have to do with the degree of the top versus the degree of the bottom. So in the situation where a horizontal asymptote does not exist, that means there is a chance that a slant does. It's not guaranteed, but there's a chance. So let's say we have 3x to the 4th plus 9x squared minus 7x plus 1. And we compare it to the degree of the bottom of 2x cubed minus 5x plus 3. If you take a look at the degree of the top and the degree of the bottom, if the degree of the top is exactly 1 larger than the degree of the bottom, there is a chance that a slant exists. A chance. So you're going to divide to determine slant. Now, a slant only has a chance of occurring if the top of the rational expression is 1 degree higher and After you take the whole out and you perform division, you have to get a remainder. Okay, let's take a look at an example. First thing I always do is go through and factor. So why don't you go ahead and pause this, see if you can factor it and see if you match mine. Okay, now that it's in factored form, I'm going to go through and see if there's any holes, which there are. It's right there. So we have this x minus 1 and x minus 1. Let's do this x minus 1 and this x minus 1 match, which means I'm going to have a hole at 1 comma something. And then if I take a look at any other factors in the bottom that don't match the top, I have x plus 1 and x plus 3, which means I have 2 vertical asymptotes actually. I have x equals -1 and x equals -3. Okay, I'm done with the factored form for now. So I'm going to go ahead and simplify this. Let's get rid of the hole. So I'm going to have x plus 2 all over. X minus 1s are gone. I have x plus 1, x plus 3. Okay, what I need to do is take the x value of the hole, which was 1, and plug it in here to try to figure out what I'm supposed to get. So I'm going to do, that's going to be 1 plus 2 on top, which I can actually just turn into 3. And then plug in a 1 here, it's going to be a 2. Plug in a 1 here, it's going to be a 4. Looks like I'm going to get 3/8. Okay, so I have 1 comma 3/8 as the location of the hole. All right, I'm going to take a look back at the original. I'm going to try to determine if this thing has what the asymptotes are with slant and horizontal. Okay, if I take a look at the degree of the top and I take a look at the degree of the bottom, it looks like the degree of the top is less, which means I have an automatic horizontal asymptote at y equals 0, which means slant does not exist. Okay, let's go ahead and get the graph rolling with this. Okay, so here's what I've got so far. I've got my vertical asymptotes on there, my horizontal asymptote, and I went ahead and put a hole where the hole's located. We know that we'll never cross a vertical asymptote. It's not possible because the graph doesn't exist there. But it's possible to cross a horizontal. So let's go ahead and figure if that's going to happen or not. So I'm going to go ahead and take my horizontal asymptote, which was 0. I'm just checking to see if it crosses. So I'm going to do 0 equals. And then you can use the factored form. You can use the simplified form. You could use the original form. Just be careful because if something is some x value has already been accounted for, so it already exists at that location, or it already accounted for. I mean, it's a vertical asymptote or it's a hole, then it's not going to count again. So I'm actually going to use the simplified version way up here, the one that I just boxed in green. So x plus 2, x plus 1, x plus 3. So that's what I'm going to do. So I'm going to do x plus 2, x plus 1, x plus 3. When you cross multiply here, this completely annihilates this denominator. Like that guy's completely gone because it's going to be 0 times. So that's going to give me 0 is equal to x plus 2. So this is going to be x is equal to -2. If you take a look back at the hole, -2 is not there, -2 is not there, and -2 is not there. So which means it's going to cross at -2. So let's go over here. We're going to have the point on the horizontal asymptote, so the dashed green line, at the x value of -2. That's a point on the graph. Okay, so since we have a point on the horizontal asymptote, we need to plug in some other points around it to just see what this thing looks like. So I'm just going to make a little tiny XY table. That's it. So just a small one. And you have to make sure that you plug it back into the original. So this is the original function. All right, so I need to figure out what's happening to the left of the vertical asymptote. Okay, so this vertical asymptote is x equals -3. This vertical asymptote is x equals -1. Okay, I already know actually what's happening to the right of -1. So if you take a look over where the hole is, so I'm looking right there. We already know where this is located, and we already know where it crosses the horizontal asymptote. So if the hole is above the horizontal asymptote, then that means the entirety of this graph is going to be above it. So I just need to give it a quick sketch. And really, it's just a sketch. So above, it's going to curl down to the hole, and then it's going to hug the asymptote. Okay, so I already know what's happening there. All right, let's plug in something to the left of -3 because I have no idea where the graph is. Maybe it's here, maybe it's there. I don't know. So let's plug in x equals negative 4. So if you plug in x equals negative 4 into the original equation, you end up getting negative 2/3. And honestly, I don't really care exactly where it's at. I just want to know if it's above or below the horizontal asymptote. So I know it's not going to hit. Yeah, I already know where it hits. So if I go negative 4, negative 2/3, I'm approximately there. So now I know where this graph is. So it's going to come in here. It's going to hug. And then it's going to hug that vertical asymptote as well. Okay, now we just need to figure out what's happening in the middle there. So I don't know if this just kind of looks like some funky parabola. Oh, it's definitely not going to look like that. I don't know if it's going to look like some funky parabola in here. I don't know if it's going to do some cubic business. Maybe it's going to do some cubic business that way. So I'm going to go ahead and I'm going to plug in something to the left and to the right of negative 2. So I'm going to do negative 2.5 and I'm going to do negative 1.5. Just try to get an idea of what's happening. So let's go ahead and plug those in and see what we get. Okay, so after plugging in some points, it looks like I do have a cubic that kind of points up in here. So let's go ahead and give that a quick sketch also. Okay, there's my graph for this thing. If we take a look at the next one, the exact same process. So I'm going to go through, I'm going to factor, I'm going to see if I have things that match here. So let's do a quick factorization on this. So if I could take out a 2, that's going to be at x squared minus 4, which is actually x minus 2x plus 2. That's going to give me x plus 2x plus 1. I see that there is a hole at the 2's. So I know I'm going to get negative 2 comma something. And then I see that I also have an x plus 1 in the bottom that doesn't have a matching factor. So it's going to give me an x equals negative 1. I'm going to go ahead and take my simplified version. So I've got my 2x minus 2, x plus 2 is gone over x plus 1. Okay, let's go ahead and plug in x equals negative 2 for this. So that's going to give me 2 times negative 4 all over negative 2 plus 1 is negative 1. It looks like that's going to give me 8. Okay, so I have negative 2 comma 8 is where the hole is going to be located. All right, let's take a look at the simplified version. Actually, let's take a look at the original. If you take a look at the degree of the top and the degree of the bottom, they're the exact same thing. So all I need to do is take a look at the leading coefficients. So it looks like I have a horizontal asymptote at y equals 2. If I have a horizontal asymptote, that means I do not have a slant. Okay, let's go ahead and get this on the graph. All right, I've got my points on there. Let's see if this thing's going to cross the horizontal. So horizontal is 2. So let's go back. So 2 equals, let's use that simplified version again. So 2x minus 2x plus 1. So 2x minus 2x plus 1. Cross multiply. So it's going to give me 2x plus 2. Cross multiply. I'm going to go ahead and distribute at the same time. If you try to move the 2 x's, you're going to end up with your x's canceling. And you're going to get 2 is equal to negative 4. When you have a false statement like this, that means you're not crossing the horizontal. There's no x's left anymore. So we're not crossing the horizontal asymptote, okay, which means I can already sketch the left-hand side. I already know what's happening. Since the hole here is above and kind of left, like trapped where those horizontal asymptote and vertical asymptote are keeping it, I know this thing is going to curl and kind of look something like that. Okay, now I don't know what's happening over here. I don't know if it's up here or if it's down here. But one of the other things you could do that we haven't done yet is you can actually just find like a x-intercept or a y-intercept. So let's see if we plug in x equals 0, what happens. So if I plug in x equals 0 back into the original of this, when I do that, the 2x squared completely cancels, and I'm going to get a negative 8 on the top. And the bottom, all of the x's cancel, and I get a 4. So, excuse me, a 2. So that's going to give me negative 4. So I'm going to get 0, negative 4 out of this. All right, let's go ahead and plot that point. 0, negative 4. So 0, 1, 2, 3, 4. There we go. I know where this thing exists now, so I'm good. Let's go ahead and give it a sketch. And remember, it does not cross the horizontal, so I'm not going to cross the horizontal. Okay, there's my sketch for this thing. All right, moving on. Why don't you see if you can do as much of this as you possibly can, come back and then check with me. You know, the first thing I'm going to do is I'm going to factor. Then I'm going to see if I can find any holes, if there are any. Then I'm going to see if there's any vertical asymptotes, if there are any. Then I'm going to use a simplified version, if it can be. So let's see if you can get caught up with vertical asymptotes and holes. Okay, so I went through and I factored. I don't have any factors that match top and bottom, so there are no holes, but I do have a vertical asymptote at x equals 2. So I can't really simplify this because there's no hole. There's nothing that matches top and bottom. So let's go ahead and take a look back at the original and look at the degree. Okay, the degree of the top is 2. The degree of the bottom is 1 if there's nothing there. Because the degree of the top is bigger than the degree of the bottom, then I know for sure that there is no horizontal. So D and E here for the horizontal asymptote. But the degree of the top is exactly 1 more than the degree of the bottom, which means there is a chance of a slant. So I'm going to go ahead and divide. Now you could do long division with the boxes, or you can do synthetic because the x minus 2. So I'm going to go ahead and do synthetic with the x minus 2. So put the 2 in the box. And let's go ahead and grab the coefficients. So 2, 6, negative 8. Either drop down or add your plus line, however you want to look at it. 2 times 2 is 4. That's going to give me 10. That's 20. That's going to give me 12. So then when I go through, the key thing here is making sure that you get a remainder. If you get a remainder, you've got a slant. If you don't have a remainder, there's no slant. So the equation itself is actually going to be y equals, in this case, 2x plus 10. Okay, now we got to keep in mind that you can actually cross a slant. So I'm going to take my 2x plus 10 and I'm going to replace the y in the original equation. So just go back to the original, got 2x squared plus 6x minus 8, put that back on top. And then on the bottom, I have the x minus 2. So I'm going to go ahead and cross multiply, see what happens here. If I multiply this out, that's going to give me a 2x squared. It's going to give me a plus 6x and a minus 20. And then cross multiply here, get 2x squared plus 6x minus 8. Okay, I see my 2x squareds cancel. I even see my 6x's cancel. So I'm going to get negative 20 is equal to negative 8. Nope, you will not cross the slant. All right, let's get this on the graph. Now, because there's no hole on this graph, I don't have any points at all. So let's see if we can find like the y-intercept or the x-intercept. Okay, so let's do the x-intercept real quick. So if I go back to the original, I'm going to plug in 0 for x. Let's see, I'm going to get negative 8 over negative 2, which is actually 4. Okay, so 0, 4. Okay, 1, 2, 3, 4. Okay, I know where this graph is going to be now. And remember, I'm not crossing that one. And I'm definitely not going to cross this one. Okay, but I don't know where the other one is. Let's see. We've got a vertical asymptote at x equals 2. Let's just plug in x equals 3 and see what happens. So if we plug 3 in, it looks like I'm going to get 28. All right, so at least gives me an idea of where I'm at. So if I'm at 3, comma, well, 28's like way up here somewhere. So let's just ballpark it. It's not necessarily that I need to know exactly where the point is. I just need enough information to figure out what the sketch is going to be.